All right, so today we're talking about thunderstorms. So you will be writing these in your notebook. It's not a whole lot to write. Okay, so let's begin with what they're defined as. A thunderstorm is a small storm that is accompanied by heavy rain and frequent lightning. You will always have them occur in a cumulonimbus cloud, which we learned about yesterday. That's the one that grows upward. And the thing that's going to cause them is when warm, humid air is forced upwards due to a cold front coming in. So, if we have warm air that is also humid, so this exact situation kind of happened yesterday where it was warm out and then a cold front came through, but the air that was in place was pretty dry air, so it didn't make that much precipitation. No thunderstorms. If the air was much more humid than it was, we would have had some fantastic thunderstorms from the cold front last night. But anyway, so if we have existing warm, humid air and then a cold front comes through, it's going to cause the thunderstorm to get created. And so in these two situations where you have cold air and warm air meeting up, only one of these two scenarios is it going to equal thunderstorms. The one that is considered unstable is this one, because the warm air is existing on the surface, so it's lower, and the cold front comes through on top. Now we have two different densities, right? Warm air is less dense, so it naturally wants to rise, right? Well, if a cold front comes through, cold air is on top. Cold air wants to sink. So now they contradict each other. So that's unstable. If instead, if it was cold air on the surface and a warm air front came through, everything would be fine. The warm air would just push that cold air to the side and replace it with warm air. Be easy. It would be happy. But instead, if the warm air is on the ground, the warm air is naturally going to want to rise up and get past that cold air. And it's going to continue to build and build and build upward on that cloud until all of that warm air is above the cold. And because there's a lot of moisture in the warm air, that's going to create the precipitation. So again, this rising motion that grows it vertically is called an updraft, which is crucial for tornadoes, which we'll get to later, and is what makes it grow. And if you remember when we learned about winds, we talked about how rising warm air is going to create a lower pressure system because it's lifting off of the ground. So if you live on the ground, you have less pressure because things are lifting upwards, and that's going to cause bad things. So you should have included all that's on the screen in your notes. Okay, so hail. Hail forms in a cumulonimbus cloud. It's the only cloud hail can form in. And it's the updrafts that cause it. So, and the hailstones get picked up by the updrafts and add another layer of ice to it. So I'm going to show you. You are going to be drawing this little picture in your notes. So you're going to draw a cumulonimbus cloud. as such. It doesn't need to be big. And there's your surface. And your thunderstorm is precipitating. So again, the growing vertical motion, that anvil shape, is created because of those updrafts. So that strong updraft is rising it upwards. And this is what makes hail. So if that updraft, and there's the ceiling of the troposphere. Okay. So if the updraft picks up a raindrop and brings it to the top of the cumulonimbus cloud, it's in the upper part of the troposphere, so it's much colder up there. So it will freeze. So now we have a little ice pellet, and it will naturally drop just from gravity. But in a typical thunderstorm, it will be strong enough that it can pick up that ice pellet again and bring it to the top of the cloud, where it will refreeze. But every time it gets brought up, it's going up through a cloud full of water droplets. So as it goes, it's just going to pick up more layers of water around that existing ice pellet or hailstone and adding a new layer around it. And so what eventually falls to the ground represents how strong that cloud is, that system. So the bigger the hailstone, the stronger the storm. And a hailstone that is usually like bigger than a golf ball size, that's a serious storm, and you are definitely going through a tornado watch. Anything larger than that, probably a tornado warning. That is a storm that has the potential and strong updraft ability to make a tornado. So you got to take it seriously. So it's really cool. You can chop open, you can hammer open one of those hailstones and count how many rings are in the hailstone. So you can count how many times the storm picked it back up to add another layer to it. This is kind of fun. On record, by the way, fun fact, largest hailstone ever dropped was in, I believe, Texas, about the size of a soccer ball. It didn't hurt anybody. I think it fell in like some field. Okay, so that's hail. Oh, yeah, larger the hail, the stronger the storm. Okay. Lightning. I'll go up here. Lightning is defined as a sudden spark as charges jump between the parts of a cloud and to the ground. It's important you know that all lightning makes thunder. We'll talk about this later. So after you do this Ed puzzle, we are going to do a little drawing activity and build a lightning bolt so you'll know exactly how they're made. But I just need this to be in your notes. Light travels faster than sound, so you'll always see lightning first. So we've kind of learned that before. You will always see something first because nothing travels faster than the speed of light. So you're going to see the baseball player hit the ball before you hear the snap of the bat. Same concept. Okay, so really quick, before I shut this off, I'm starting with the good stuff. Okay, there's little bit things that you need to take a note in here. Only the highlighted portions. So I'm just going to zip through this really quick. So first off, this is not anything to write. There are three main types of lightning. Cloud to cloud, which means it just travels within horizontally, never strikes the ground. Cloud to ground, that's the one that you're probably most familiar with. And ground to cloud. So the ground to cloud one is usually something that is conducive to conductive. So something metal, usually like buildings. So the Eiffel Tower, the Empire State Building, those are oftentimes going to be struck by lightning, and it's more of a mutual of the metallic building is trying to connect up with the cloud. And that'll make more sense when we talk about it in class. Okay, so here's your highlight. You need to write down that if you are outside in a lightning storm and you are in a flat open field, like a soccer field, you need to ball yourself up and get as close to the ground as you can without lying flat. Because if you're lying flat, you increase your surface area that the lightning bolt can hit you. But if you ball yourself up and make yourself a much smaller object, there's fewer places for the lightning to strike you. And the whole point of that is to not be the tallest object. Lightning is terrible at aim. It could be trying for a telephone pole, it could be trying for a tree and get you instead. So it's really bad to stand under a tree in a lightning storm because it often misses and it can get you easily. Okay, if you are outside, stay away from metal and water. They are electrical conductors. So it travels really fast through it. And that's even if like you're in the pool, if it gets struck like far away from you, that will travel through that water so fast you won't have time to get out. So, and they'll close the pool down if I believe if lightning is within a 1 mile radius, or even farther than that, 5 miles maybe, they shut the pool down because it's really dangerous. Obviously, don't go golfing when it's lightning. Okay, indoor safety. Stay away from windows. It can travel through windows. Stay off your phone and your computer. Anything plugged into the wall can easily electrocute you. If your house gets struck by lightning, it'll travel through all the electrical outlets in your house. So like this guy, he got electrocuted. Lightning got into his through the outlets in his house, and his phone was plugged in to his charger, and he was on his phone, and it electrocuted him. And then again, avoid water and metal pipes. It's not advisable to take a shower or do the dishes during a storm. It's a great excuse. Tell your parents. I feel like there's lightning nearby. I just can't do them. Okay, my last couple ones are just for fun. If your hair does this outside, duck. Because at that point, your hair is trying to connect your body to the cloud above it and get electrocuted. So these people that are smiling, yeah, they shouldn't be smiling because they're at risk of getting struck by lightning. Lightning does strike the same place twice, many, many times. That's just an old saying. And last, the good old Lichtenberg scars. People who have been struck by lightning, and by the way, being struck by lightning does not mean you are absolutely going to die. There are more survivors than are killed, but they will leave these awesome looking scars from where you can see the blood vessels of where the energy traveled through. It's pretty cool. Okay, that's it. Now just wait and we will do the lightning little diagram in just a moment.